when we began to look at the sine and cosine function, we compared what was going to happen as far as transformations of the parent functions of sine and cosine to the parent function of a line, the parent function of a quadratic, the parent function of an absolute value. And we actually looked at graphing form of a quadratic, and we talked about the transformation of parent function points. We said what's going to happen to the x is what's inside the parenthesis, and it's going to happen to the x in the inverse order of operations. What's going to happen to y is what's outside the parenthesis, and it's going to happen to y in the inverse order of operations. Okay? And then we began to really just look at the sine wave and cosine wave, and we looked only at the A thing. And here's what we said. We said what is going to be happening to y is that my original y would be multiplied by A, right? My original y would be multiplied by A because it's outside the parenthesis, and what's outside the parenthesis happens to the y, and it happens to the y in the order of operations. And so we came up with a rule for that. We said that the amplitude, because the original amplitude was 1, and if I take that original amplitude of 1 and I multiply it by A, I'm going to get A. And so we said that the amplitude was equal to the absolute value of A, right? And it was because of what's outside the parenthesis is happening to y in the order of operations. So all of my y's got A times bigger. And so it changed my amplitude. And just so we remember, we used to go 1 to negative 1. And if A was equal to 2, then that means that we would go from 2 to negative 2, right? My wave is just taller. Any questions on that? Okay. Now, we haven't really talked about what happens if it's over here. We haven't done that yet as far as sine and cosine. So we hadn't messed with that. But then we actually messed with this right here. We said, okay, what happens if it's k? Well, what does the k do? Well, it's inside the parentheses, so it's happening to x, and it's happening to x in the inverse operation, so we would do the inverse of multiplication, which is division. And when we talk about x, what is the normal distance x goes? 2 pi, and we call that the period, so the normal period was 2 pi. And we said what's going to happen to x is what's inside in the inverse order of operations. So we would do the inverse of multiplication, which is division. We would get that the new period is 2 pi divided by k. We did the inverse of division, which is multiplication, the inverse of multiplication, which is division. And so we came up with a rule for amplitude and a rule for period based upon doing to y what's outside and undoing to x what's inside. Now, what that did is it took a wave and it either stretched it vertically, made the amplitude bigger, or it took a wave and it stretched it horizontally, shrunk it or stretched it horizontally. So we're talking about stretching. We're not shifting left, shifting right, shifting up, shifting down. When we messed with A and K, we stretched vertically or we stretched horizontally, okay? Because we're multiplying or dividing. Now, when we're messing with the C and the H, those are additions and subtractions. So now we're going to be translating to the left or translating to the right or translating up or translating down. Remember that what is on the outside is going to happen to the y in the order of operations. And so if there's a multiplication over here and an addition over here, then if I took my parent function y, it would end up at a times y plus h. We apply the order of operations. What was outside was multiplication by a and addition by h, so my new y will be at a times y plus h, the transformation of the parent function. Now the a, graphically speaking, just stretched my wave vertically, but the h is added, and that's going to shift it up vertically. In other words, this used to be my midline. My midline is going to get shifted up. And so now it's starting here instead of down here. It's starting up here and doing its little thing, okay? So the midline was the x-axis, but the midline shifted up by h so that the whole thing shifted up there, okay? So if that h was a 2, we'd just act like 2 is the x-axis, and we'd have the 0, 1, negative 1, whatever, okay? We'll talk about that in a minute. Does everybody understand that? That looks very non-confusing, doesn't it? All that stuff there. Hopefully we kind of made sense out of that. Now, what's inside the C is happening x, but it happens in the inverse order of operations. So if you see subtraction, what's really happening? Addition. So we're really going to add the C to the x. Now if we add the x, what happens? Shifts to the right. We would normally call that a horizontal shift, but with sine, cosine, and tangent, we call it a phase shift. Okay? Now, that's only going to be, your phase shift is going to be C if there's not a K. See, if K is 1, your phase shift is C. But if you put something else in there, that K is going to move it. It's going to mess with it. And so what's really going to happen, if you want to calculate your phase shift when K is not 1, your phase shift is really going to be plus C divide K. Your phase shift will be positive C over K. Now, why is it going to end up like that? You do it in the inverse order of operations. Where is x going to end up? Well, we had multiplication and subtraction. What's going to happen to x is going to happen to inverse order of operations in the inverse order. So you're going to do inverse of subtraction, which is addition. And then you're going to do the inverse of multiplication, which is division. And you'd have C over K for a phase shift. Now, if K was 1, it would just be the C. All right? Everybody see how we got that? Now, I kind of made a mess out of that, but hopefully you can see that, and maybe you would want to go back and watch the video on that. But what I'm going to do is clean this up, and then we're going to write rules that we just discovered. If you didn't discover them, you might watch that again. And if you don't see how it connects to parent function transformations, you might want to go watch the video on parent function transformations to reconnect to that. And so, let me get the last little piece there. Let's go back and put y equal a sine of k theta minus c plus h. Wow. If we're going to graph, we need to know the phase shift, the amplitude, the period, and the horizontal shift. Okay? So we're going to need to know which way that thing's going. Okay, so let's just talk about that. How would we find amplitude? We need to write formulas here. Amplitude is equal to absolute value x. Absolute value a. Amplitude, I'll write it again, sorry. This is hard when you're watching a video and I'm erasing, I know. Amplitude is equal to absolute value a. What about period? 2 pi over k. These rules apply to both sine and cosine. What about phase shift? Phase shift is c over k. What happens to x, my phase shift, is what's inside in the reverse order of operations. So we would add c and divide by k. You'd have c over k. The vertical shift is h. If we wanted an equation of the midline, it would be x equal h. Y equal h, excuse me. Y equal h. I was just thinking that it was the x-axis, but the x-axis is y equals 0, right? So if it shifts up, it's going to be y equal whatever that was. Shifts down, y equal whatever that was. So our midline changes, okay? So these are all the rules that we're going to be using to do the next big old chunk of work, okay? And they're based on the fact that what happens to y is what's outside the parenthesis, and it happens to y in the order of operations. Please excuse my dear Aunt Sally. And what's inside the parenthesis happens to x in the inverse operations, inverse order of operations. Sally, Aunt, dear, my excuse, please. Okay? All right, so we've laid the foundation to why, so let's just look at some examples. We'll go to number 16 on our worksheet. We have sine 2 theta plus pi. Y equal sine 2 theta plus pi. In parentheses, I knew that. Now, let's put the understood stuff just for the fun of it. There's an understood a of 1. There's an understood h of 0. And let's just go through the whole thing just so we get the practice, okay? So, what is my amplitude? The amplitude is equal to the absolute value of a, which is equal to 1. And so it's plus or minus 1. But we can already see it's 1. So it's really not plus or minus 1 that gave us the equation, right? So the amplitude is really 1. Because we can see the 1. It's the absolute value of a, but it's obviously positive 1. That's what we have. Now what about the period? Well, the period formula is 2 pi over k. What's the value of k? That 2 right there. So it's 2 pi over 2, which is pi. So my new period is pi. Now, we do something with that period. What do we do to that period to figure out how to grid it out? To get the gap size, we divide that by 4. And so when I make my scale, my x scale, I'm going to do pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Right? My phase shift, which is my horizontal shift, is equal to my C over my K. My C is I heard pi. See, it's got a minus in the formula, right? That's really the opposite. See, we're going to undo addition by subtraction, negative pi over 2. Undo addition by subtraction, negative pi. Undo multiplication by division, divide 2. See that? All right. My vertical shift that 0 out there that was understood. So my vertical shift is 0. My midline equation, well, it didn't shift. So it's still y equals 0, the x-axis, right? It's h, which is understood 0. That should be enough information to graph. See how we found all those things? Because the question was, why is phase shift negative? We have multiplication and addition. Phase shift is what's happening to x, because it's your horizontal move. What's happening to x is going to happen by what's inside in the inverse order of operations. You're going to undo addition by subtraction. There's the negative. Undo multiplication by division, negative pi over 2. So it's C over K, but C is really, it was minus a negative. So plus pi is really minus negative pi. It's easier to just think undo, subtract, divide. There it is, okay? You might forget all those C's and B's and A's and K's, but if you understand the parent function transformation, it's really easier. No, undo, addition, subtract, divide, boom, there it is, okay? All right, any questions so far? So we're going to think about how to graph this. First of all, I need to understand that my midline is still 0, so I'm going to be working off of the x-axis. My amplitude is 1, so I'm still going to go from 1 to negative 1. So I kind of thought about, did I need to move my midline? What about my amplitude? So now that the y part of my grid kind of figured out. X part of my grid is going to go to pi. That was my period. How big are my x's? They go to pi. I want to divide it into 4 chunks. Pi over 4. So there's halfway, pi over 2. Half of that, pi over 4. And there's the next mark, 3 pi over 4. Now, some people were having trouble with that, so let me just find a place to write this. You might want to say, well, it's pi over 4, so I'm going to have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. If you just want to write it like that, those 2 of those, 3 of those, 4 of those, first, that way you don't mess up. Then just go back and reduce. This one reduces to a half, pi over 2. This one reduces to just pi. It might be easier just to say 1 of those, 2 of those, 3 of those, 4 of those, and then go back and reduce later. I think that's jamming some folks up, okay, when we reduce as we go. Anyway, so that's all the stuff. We got all our shifts in there. Whoops, we didn't get our phase shift, did we? It shifted to the left, pi over 2. Now, let's look at this. This is important. So this is going to be negative pi over 2. Negative pi over 2. All right. Are we ready? Let's think about where it would have been. What is the sine? We're talking about sine. We're talking about sine. What is the sine of 0? Okay, so the answer would have been here, but what happened? It shifted left, pi over 2. Okay? Now, what would have been pi over 4, right? What would have been pi over 4, what is the sine of pi over 4? Well, we don't care about that. We're just kind of going to the next thing, right? Our four little things. What would have been next from 0? 1. So it would have been a 1 here, but it gets shifted left pi over 2. Oh, boy. Oh, I messed that up. Let me start over. You're right. I was getting, oh, boy. I shouldn't have done that. Thank you very much. I've got halves and fourths and... Okay, we'll do this again. Sorry about that. You don't have to erase anything. I just need to make a better deal over there. We've got a pi over 4. Thank you. A pi over 2. A 3 pi over 4. A pi. And then we've got pi over 4 negative. And then we've got negative pi over 2. Okay. Let's do this. Let's go ahead and do the original, and then let's shift them all. 2 jumps. Okay? So let's just do that. That'll be easier. So let's say, okay, what was the sine of 0? 0. So I would have started at 0, gone up to 1, back to 0, down to negative 1, and back to 0. That's where I would have been, right? Now it's going to shift left pi over 2, which is really 2 jumps. So everything goes 2 jumps backwards. Okay. So this point is going to go 2 jumps back, so it's going to end up where the 2 before it was. See, this one's moving all the way to there. That makes sense? And this point right here is going 2 jumps back. So it's going to go to there. And this point is going to go 2 jumps back. That's crazy looking. It's going to go to there. And this one is going 2 jumps back, so it's going to go to there. And then this one would go 2 jumps back. So I kind of got lost. I think I went 3 jumps over here. Yeah, it should have been here. Should have been here, right. Yeah, and then this should have gone back to here, 2 jumps. So everything moved back 2 jumps, and so we're to there. That was weird, I know. So we took all of our points, but we said, okay, I got to back up. Okay? That was probably kind of weird to say. This was at 0. I just need to slide it to the left, pi over 2, right? This was at negative 1, but I need to move it over by pi over 2. This point was at 0. I need to move it over to there. This point was up here. I need to move it to there. This point was here. I need to move it to there. All I'm doing is sliding every one of those original points to the left pi over 2. And then I'm going to graph it. Okay? Make that face. That's a little bit hard to draw in a limited amount of space. Any questions on what we did? Now, you know that we could have just put this equation in y equal, and we could have built a table and just got some points, but they could have been really crazy points. So we're trying to look at it from the original 0, 1, 0, negative 1, 0, shifting up, shifting down, shifting left, shifting right, stretching up, stretching down, stretching left, stretching right. Okay? Any questions on that? Yes. All right, number 17. Number 17. So number 17, we have y equal 3, whoops, cosine's outside, 3 cosine theta over 6 plus pi over 3, and an understood plus 0 for a vertical shift. Okay, so we've got all our formulas on the left, and so our amplitude is the absolute value of 3, which is 3, which is what I should have done last time, right? If that had been a negative 3, it would have been absolute value negative 3, which is 3. All right, we did better this time. All right, and then we're going to have period. The normal period is 2 pi, but to get the new period, we take 2 pi divided by k. So we're going to have 2 pi divided by, what's my k? 1/6. Divided by 1/6, that's kind of like having 2 pi over 1. To divide by a fraction, you multiply by its reciprocal, so that'll give us 12 pi for the new period. What we know from that is if we want our gap size would be 12 pi divided by 4, which is 3 pi. So we would get it out, 3 pi, 6 pi, 9 pi, 12 pi, before all the phase shifting goes on. The phase shift is equal to add c divided by k, because we're undoing what's inside in the reverse order of operations. Let me show you again what we're talking about. We have multiplication of 1/6 and addition of pi over 3. You're going to undo that addition by subtraction, which would give you minus pi over 3 divided by 1/6. Undo addition by subtraction, then undo multiplication by division. So we have negative pi over 3 divided by 1/6. To divide by a fraction, you multiply by the reciprocal. 6 and 3 are going to 6, 2, so you're going to get negative 2 pi. So your phase shift is negative 2 pi. That means it shifts to the left 2 pi. Shifts to the left 2 pi. My vertical shift is that understood 0, which means that my midline is y equals 0, the x-axis, so it's where it used to be. So we know the amplitude, period, phase shift, vertical shift, midline, so we should be able to graph. Okay? All right, we have to have a place to graph. Let's try to make a place to graph here. All right, my midline stayed the same. I'm going to start right here. Your amplitude is 3, 1, 2, 3, negative 3. So we took care of the amplitude. We've got our midline of y equal 0. It didn't shift up or down. We have a period of 12 pi. We're going to divide that into 4 sections. We're going to have 3 pi, 6 pi, 9 pi, and 12 pi. we would have negative 3 pi. That wasn't a very good ditto. Negative 3 pi, still wasn't a good ditto. Negative 6 pi, negative pi, negative 12 pi. We may not need that much. We are going to have a phase shift of negative 2 pi, right? And we're just going to kind of guesstimate that 2/3 of the way as we go. All right. So let's think about where things would have been. We're talking about cosine. Where's my first cosine? It would have been at +1, but it's now at 3, right? But what's going to happen to it? It's going to get shifted to the left by 2 pi. So it's going to be at negative 2 pi. See that? What's your next cosine hit? 0. Would have been here, but it's going to shift. It would have been here. Just a second. Temporarily experiencing difficulties. Please stand by. Would have been there, but it's going to shift left 2 pi, and it's going to end up here, right? The next hit would have been at, and it would have been negative 3. At 6 pi, it would have been negative 3, but it's going to shift to the left, so it's really going to be at 4 pi, right? The next hit would have been at 9 pi, and it would have been a 0, but that's going to get shifted over here, 2 pi amount. It's going to end up there. The next hit would have been at 312, would have been 3 pi again, but it's going to get shifted. Let's see what happened. So we're still using our 1, 0, negative 1, 0, positive 1. We're just doing the shift at the end of that. Any questions there? That's a lot of stuff, isn't it? Wow. Pretty complex. Any questions on that? That's probably plenty for one day. We'll let you think about that a little, and we'll do the next couple of problems tomorrow. Appreciate your attention. That might be worth watching again.